Let's start with a problem every educational app has right now. We mistake clicking for learning. A student clicks a button, a shiny progress bar fills up, declaring they've mastered a concept. But outside that interface, that mastery shatters completely. Earning 1,000 gold coins or narrative points in a digital game doesn't mean a student understands a loop, a variable, or a physics equation. It just means they learned how to play the game. To close this gap between engagement and actual comprehension, Secured Me Education built a framework called AlgoQuest. It takes the structure of a classic 1980s choose-your-own-adventure book, where your decisions branch out into different paths, and adapts it into a modern tool for teaching highly deterministic subjects. We're talking about material that requires absolute precision: algorithms, advanced mathematics, and physics. The system uses a mascot named Qubit to guide students through these paths. Qubit's job is strictly to act as a narrative companion. He is there to help you navigate, not to grade you. That friendly exterior sits on top of a highly rigid engineering environment. While Qubit offers hints, the background system is quietly running hard calculations on the student's actual work. High engagement is useless if it tricks a student into thinking they understand a concept. A truly rigorous system has to completely separate the fictional story from the mathematical proof. This separation is what AlgoQuest calls its decoupled architecture, the primary solution to the gamification fallacy. The framework uses large language models, specifically Codex or Gemini, but restricts them entirely to generating the narrative connective tissue and brainstorming ideas. The opposing force is the execution layer. Only versioned, deterministic rules evaluating actual, runnable code are allowed to grant academic proof. The boundary is absolute. The artificial intelligence builds the fantasy adventure, but the execution environment verifies the learning. In the AlgoQuest system, artificial intelligence is structurally forced to be a workshop, never an authority. To understand how this works at scale, we have to look at how AlgoQuest updates that gamebook concept into a modular mission graph. Instead of numbered pages, the structure relies on a network. A central story anchor splits into multiple choice branches, allowing the user to make a decision before those paths reunite at a convergence node. The platform contains 6 distinct worlds to explore. Each world adapts for 6 audiences, from 5th graders to teachers. Inside each path, the system pulls from 40 unique interactive prompts. Across 3 languages, the matrix generates 4,320 localized possibilities. To manage this, the system uses an adventure outcome matrix. This defines the rules so that historical and scientific facts remain identical across every single path, but the required vocabulary and the complexity of the digital artifacts scale to match the user's age. Because the permutations are massive, a student cannot simply memorize a sequence of clicks to pass. They must actually understand the underlying system. The way they build that understanding relies on a philosophy called action before jargon. Staring at a blank screen is paralyzing. Instead, the student is given a prefab, a functioning, modifiable piece of code that takes about 15 minutes to experiment with. These prefabs run in Google Colab notebooks and output raw ASCII text alongside the narrative. Reading a story and clicking Next on a dialogue tree provides zero evidence that a student comprehends an algorithm. True evidence requires them to step in, change a variable in the script, and immediately observe how that change affects the output. Every time the student runs the code, the system generates an algorithm artifact receipt. This receipt logs the exact modifications made and the test results, creating a digital proof of work. By starting with a modifiable prefab rather than a blank page, the student bypasses the intimidation factor and immediately engages in verifiable engineering. To keep the fiction from polluting the facts, AlgoQuest uses a safeguard called 2 screens, 2 truths. On the left side is the adventure view. This narrative interface holds the world-building, magic, compass, and experience points that motivate the student. On the right is the study view, a sterile dashboard verifying test outputs and supplying scientific sources. Left screen decisions might grant cosmetic items, but carry no academic weight. Only a successful, evaluated code run grants a knowledge token. Because in-game achievement badges can never inflate or overwrite academic knowledge tokens, the system protects the integrity of the evaluation. To physically enforce this boundary, the AI models are constrained by a gating mechanism known as the wake-up kit. The system packages a narrative envelope, a restricted data payload with the mission and hard constraints, and sends it through a firewall to the AI. If the model returns a mastery score, that packet hits the firewall and is instantly deleted. The architecture denies the AI any authority to invent canonical prompts, alter historical facts, or grant academic tokens. This strict data gating extends to student privacy through a system called the Tenebris protocol. Tenebris automatically purges fine-grained telemetry, like how fast a student types or their vocal hesitations, to prevent the AI from generating unauthorized psychological profiles. A large language model is only safe in a classroom when its capacity to judge a student is hard-coded out of existence. What remains is a verifiable closed-loop system. The student reads a story prompt, engages in prefab execution, generates an artifact receipt, and earns a true knowledge token. Qubit remains a guide. He points the way through the material, but he is never the arbiter of the student's success. The true innovation of the AlgoQuest platform lies in the use of systems architecture to securely containerize the AI. In-game points exist solely to tell the story of the user's effort. Only executable artifacts and deterministic logic can prove actual mastery. This strict separation is exactly what enterprise-grade educational technology will require from systems architects going forward. Artificial intelligence can build the world around a student, but human intention and absolute deterministic logic must always remain the ultimate authorities.